In this lesson, we're going to look at how to identify domain and range by looking at a function's graph. We talked about domain and range before, but we were looking at the set of ordered pairs before, and now we won't be looking at a set of ordered pairs or even at an equation, but we'll just be looking at the graph. So domain is all the possible x values that we can have on the graph, and it's usually given in interval notation, although it can also be given in set builder notation. And the way we do it in interval notation is we give the farthest left x and then the farthest right x. The range is all the possible y values, and the way we do that, also in interval notation or set builder notation, but it's always the lowest y value to the highest y value. So domain is x's and range is y's, and if you can keep that separated, you've got the battle half won here. Okay, let's determine domain and range. So the first thing I'm going to do for domain is look at the graph and find the furthest left x value and then the furthest right x value. And I see that the furthest left the graph goes is to -6, but I see this open circle here, which means that -6 is not actually included in the domain. In other words, there is no point on this graph that has an x value of -6, because you can see that's what the open circle is telling us, is that, hey, there's no graph here when x is exactly equal to -6. So I just need to show that when I write my domain down, and that's what we use parentheses for. It means, that -6 is not included. I just need to make sure -6 is left out. So parentheses -6, and then the furthest right we can go is to 0. And there's a closed circle at 0, which means that there is a point on the graph that has an x value of exactly 0. So I can put 0 bracket. Now in set builder notation, I need to say that x is between -6 and 0, and it can be equal to 0. So if you remember from when we did our compound inequalities, to use set builder notation, we say the set of all x's such that x is between -6 and 0. And the way I do that is I write down the -6, and then a less than sign, less than because of the parentheses here. The open circle and the parentheses and the less than sign, they all go together. And then here, because of the bracket, I'll have a less than or equal to sign. So x is stuck between these two numbers, but because of the bracket here, it can be equal to 0. Right, now let's do range. So again, I'm looking for y values this time, and I need the lowest y value, which looks like -3, and the highest y value, which looks like +4. But again, there's an open circle at +4. So there is no y value on the graph that has a y value of exactly 4. And so I've got a parentheses here. And when we do our set builder notation, we'll again put the y in between the -3 and the 4, but we'll put a less than or equal to sign here and a less than sign here. So -3 is less than or equal to y, but y is also less than 4. So y is stuck between those two numbers. Okay, now domain and range for this semicircle. First of all, let's look at where it starts on the left and where it ends on the right. We're looking for x values. When you think left and right, think x values. And I can see that the furthest left is -2 and the furthest right is +2. So in interval notation, our graph includes all the x values between -2 and +2. And in set builder notation, we just want to show that x is between -2 and +2, and we use the or equal to show that it can be equal to each of those numbers. For range, I'm thinking lowest y value to highest y value. So the lowest y value is 0, and I do have a bracket because there actually are points on the graph with y value equal to 0. And 2 bracket because there actually are points on the graph, or 1 point anyway, with a y value equal to 2. And in set builder notation we say that y is stuck between 0 and 2. So again, the or equal 2's correspond to the brackets. So here's another graph. Determine domain and range. So domain is left x value to right x value. Now the furthest left that this graph can go is negative infinity, because it's just going to keep going here. And the furthest right it can go is to 4. That's where it stops. So the domain needs to be negative infinity to 4. And I do have a bracket on the 4 because I do have this closed dot here. And remember that infinity never can use a bracket symbol. So in set builder notation we would say all the x's as long as x is less than or equal to 4, because we want to include everything that's smaller than 4. Alright, then range, we would go lowest y value to highest y value. Now the lowest is 0 and the highest is infinity, because even though this is going to the right faster than it's going up, it is still continuing to go up. So you could conceivably go as high up as you wanted to if you're willing to draw the graph big enough. So from 0 to infinity is our interval notation. And then the set builder notation is all the y's such that y is greater than or equal to 0. And last one, this is an absolute value graph. The domain is the farthest left x value to the farthest right x value. And even though, well, we don't see closed dots here or arrows, but you can assume that since the graph kind of runs off the page, that it would continue going if the graph were bigger. So the domain is negative infinity to positive infinity. The graph continues forever to the right. Okay, now range. Well, let's do set builder notation. Since this is all real numbers, the set builder notation is just x such that x is a real number. Now the range, we do lowest y value to highest y value. And again, this is continuing upward forever. So the lowest is negative 4, and the highest is infinity. And so in set builder notation, these numbers are all the numbers that are bigger than negative 4. So we'll say all the y's such that y is greater than or equal to negative 4. Okay, and I did have that negative left off, but it's been fixed now. So set builder notation is really just the inequality that describes your interval.